Hello, everybody, and welcome to the September 20th, 2022 iteration of the Kubernetes SIG Windows community meeting. As always, these meetings are recorded and uploaded to YouTube, so be sure to adhere to the CNCF Code of Conduct. Let's jump right into announcements. First announcement is still the KubeCon North America Contributor Summit. If anybody hasn't signed up and is planning on attending, please sign up. And there's still, I think the call for proposals for talks for that is open until the end of this month. I'm not sure the exact date, but I think there's another week and a half. So if anybody's interested in speaking there, go ahead, or please go ahead and submit a request. The next announcement here is that we've released another version of the Windows debug image that I think James has put together, wired up with the crew plugin, and have demoed here before too. This new image includes some more tools for doing diagnostics and debugging for network related things, and also includes the WRPR file that lists all of the HCS events to collect if people want to try and debug any containerd or HCS issues. Does anybody else have any announcements or questions? All right, next we can go into the new contributors welcome. But actually everybody on the call here has been people that contribute. So I think we can skip that part and go right into the agenda. I added this real quick. This is more of an FYI for everybody, but this PR here is, let me open it. This PR here that Amim is starting is removing the user space portions of the kubeproxy for Windows. So this, I added this here just as an FYI. I think it's been marked as deprecated for a couple of releases and there's issues tracking the deprecation. But if anybody is interested or sees any concerns with that, please speak up. I see Jay just joined. Jay was just announcing or giving everybody a heads up that we're planning on removing the user space portions of the kubeproxy. See if anybody had any concerns. Next, Fabian, did you want to talk about this?
Yeah. Hello, I've added the Windows support for the in-place vertical scaling, and I'm working on the E2E tests for it. Right now, on the PR in-place vertical scaling is just for Linux, and I've started working on the Windows support for it.
Awesome, and I think that I know that containerd already has some support for resource resizing too, so that's good.
On Windows, yeah, we added that I think last year or so in containerd, so it should work as intended.
Awesome. This is great. This will be super helpful.
There are a couple of things to note, which might be interesting, is the fact that what was it? That CPU scaling doesn't work for 2019, only for 2022. Or I think it was for 2004 onward, which we do not support anymore, so 2022. But the other one should still work for 2019.
Do we know, does that just basically no op, or does the shim or containerd give an error if you try and do that on 2019?
That's a good question. It's been a while since I looked into that. I think it was erroring out, but I'm not sure. Okay. I think we do have integration tests for resizing the containers in containerd. But it's been a while since I saw those. So I can take a look for next time if needed.
So
awesome.
I thought they kept for in-place pod vertical scaling was still like in alpha or review or something.
Yeah, so they've Signode has been trying to get this merged, I think, since maybe 122 for a while. The latest is at the end of 125, they merged all of the CRI changes so that they can get the, I think they were having a lot of trouble trying to juggle landing the kubelet changes, the CRI changes, and then the container runtime changes, and especially trying to get any sort of test coverage on that. I think they were pretty close at the end of 125 with cryo support, and then there was some private containerd packages that supported it for Linux. But at the end, everybody in SIG node just decided to just merge the CRI API changes because they'd been kind of reviewed and almost merged for a couple releases. And the hopes are that it will go to alpha in 126. And then I have no idea if it's going to stay in alpha for a while. This is kind of a huge change across many different parts of Kubernetes. Mainly node in the container runtime, but it has implications for, you know, scheduling and things like that too.
So how, I guess I don't understand how, if it hasn't merged into Kubernetes, how did we add tests for it for Windows?
You mean the integration tests that I mentioned? Those are in containerd. You know, basically what we did in containerd was just the plumbing, which basically passes through HTS shim, all the right bits that were necessary for it. And now what Fabian did was basically the plumbing from Kubernetes API to containerd, basically, just passing them through. So I think pretty much regardless of where the cap actually goes for in place pod scaling, this is still valid in either case.
Also, it's in place because it's not like Kubernetes changes the pod CPU.
Yeah, it
Word.
resizes the pods without restarting the pods.
The kubelets in real time expands the CPU allotment at the kernel level by telling containerd to do that or something.
Yep.
Yeah, I think that's the goal. So I'm guessing for this PR, something else tells the kubelet that there's been a resize operation, and this PR just reacts to that for Windows. Is that correct?
Sir, can you repeat the question?
I was gonna say, I think that for this PR is only handling the reactions saying that the resources are being resized. This PR doesn't touch anything that was triggering those resize operations.
Yeah, exactly. I think those resizes are requested through the Kubernetes API itself, right?
Yeah, and I think that's what still needs to be merged with and tracked for the big PR.
All right, so this is like lower layer, lower in the stack where it works. We just haven't got the whole user end flow working. Got it. Okay.
Yeah, exactly.
Cool. Thanks.
Yeah, so this big PR that hasn't merged yet, I think, is in charge of doing all of the making sure like handling and deciding when and what to resize them the resources to, making sure that the container hashes are either updated or not updated properly. I know that was a big issue, and also making sure the API objects are updated correctly. The seems like this PR just handles after that's all been done. We need to send messages to the container runtime to actually do the resize.
Cool. So we'll be ready when that other big one changes. That's awesome. Thanks.
Yep.
Yeah. It's nice to see kind of a huge feature go in with potentially Windows support right at the gate, especially in alpha. Well, thank you. Anything else about that, Claudio, Fabian?
Not for the moment. I'm working currently on the tests to see if it really does. I tested only on the API part. Okay, sounds good, and keep us updated.
David, did you want to talk about this?
Sure, I have a short demo prepared. If I can show that.
Okay, let me stop my screen share. Are you able to share, or do you need somebody to give you permission?
Let's see. think I'm able to share. Can you guys see my
Yeah, I
screen?
can see a slide presentation, it looks like.
Okay, yeah, I have some few background slides as well. Okay, yeah, so thank you. So yeah, I wanted to show a project today our summer intern Nico Hobart worked on to help improve our troubleshooting tooling. We wanted to share this today since we thought it might help others in the community as well. So just to give a little bit of background, so to date we have a few mostly PowerShell scripts that we use to debug container networking. So they take a snapshot of the container networking state or capture the control plane activity or the data plane activity here. And there's also a tool called Packetmon that can do packet capture, filtering, and counting of packets as well. There's a few problems with this approach today and why it doesn't scale well with Kubernetes. So all these PowerShell scripts, they all require direct access to the nodes like over SSH or RDP. And actually many of our users and customers struggle with obtaining this direct node access, and at least for production clusters. The scripts can also only be run at one node at a time, like you have to SSH or open up some exec window into every single node and run it there. However, Kubernetes is kind of a distributed system, right? So we want observability into multiple moving pieces. And the other problem is that these scripts are, they're meant to log kind of everything, so we don't miss anything. So there's obviously a lot of activity in Kubernetes, and we need more granular or selective observability. And lastly, the scripts don't really have that context of Kubernetes. So like you have to work on figuring out what the IP address is for a given pod at a given point in time, etc. All of these things are moving pieces, so that makes things more complex. So just to demonstrate that further, there's a few examples I have. So let's take a look at two simple examples. So these are real world examples as well. So the first one is, imagine you have some user that has a service exposed to a load balancer. So very basic, but imagine the pods of the service are spread across 16 nodes. And so this user reported, when an external client tried to connect to the load balancer, 5% of the requests were timing out or they were having issues. So now the question is, which node has the problem in it? And since there's 16 of them, obviously the PowerShell scripting approach doesn't work very well. So we need better tooling at the cluster level. Example number two would be, even just on one given node, there's a lot of activity. And what if we want to take a look at a particular pod, look at it in detail? So running that is not very simple, or it's possible, but there's no good user. Another example could be HNS and many other components run on each of these nodes independently, but any one of these could crash or misbehave at a particular node and impact the overall cluster health. And so we need tooling to check the consistency of the state across the nodes as well. So the tool that we came up with is called WC Inspect. It's a first attempt at improving this experience. So it allows you to gather the network state from different nodes. It allows you to do a packet capture at a node or a pod level. It also allows you to retrieve packet counters, either from actively running packet captures, or the VFB port counters of pods. Gather some stats there as well that can indicate the network health. And all of this is deployed as a Kubernetes daemon set. So how does it work? Very quickly. We don't have much time left, but it's basically deployed as a daemon set. So we have a server that gets created, a daemon pod that gets created on each of the Windows nodes. And it's implemented as a gRPC service to allow for more efficient communication. And it exposes kind of some server streaming RPC methods, which when called will collect any requested information from the nodes, etc., and kind of stream it back to the client. So we have a CLI that is the client, which kind of processes the output from all of these nodes and displays them to the user. So without further delay, let's jump into the demo. So I have a demo environment where it's basically just a basic AKS cluster where I applied the daemon set already. I applied this WC inspect daemon set. So I'm gonna jump into my RDP session here. This is a jump box in the same network as the AKS cluster. You can see the my RDP window, right?
Yeah.
Okay, good. Okay, so so here on the right hand side, I have the WC inspect CLI. So, and here on the left hand side, you can see some of the resources. So I have a sample 19 service with sample 19 pod, and I have another WinWeb server. Nothing too extravagant. In the right hand window, I have the WC inspect CLI. There's a few functions we have. So the most basic one we could start with is the HNS. So we can view any of the HNS resources on any node that we're interested in. So this is, for example, showing all the HNS networks on each of the nodes. We can also print the JSON from any of these resources. Then we have capture functionality. So that's the more important feature. So let me, for example, run a curl on this external IP, right? So I'll set that up. I have a load generator here. So it'll kind of run a curl once each second. And up here, I will define a capture. So let me show that. So we can define filters either on IP addresses or the protocol type. So I'll be using those filters. So I'll be capturing only the TCP SYNs that match the external IP address. And I'll be running this capture on the entire cluster, so on all of the Windows nodes. Starting the capture here, let me send the traffic to this IP address. So that's the sample 19 service. So it's sending traffic once a second. You can see the 5 tuple being received here. So you can see this IP address is from the client. I don't know if you can see that. And then this was the external IP, so the load balancer. If we want to see the counters, we can also do that. So in this case, the sample 19 is only one pod. So we can see there's no counters on this node that matched, but here we could see there was 27 packets received, or 27 TCP SYNs. Another example, I could show you the east to west traffic as well. So we can, the capture command can also run on pods. So let me open up, I'll exec into the WinWeb server pod. So that's the WinWeb server pod. That's this one. And I'll be running another capture now. This time I'll be capturing only on the pod directly. So this is going to capture all TCP SYNs, any packets coming out of the pods that are TCP SYNs. And that. And I'll just be curling the sample 19 service from the WinWeb server pod. So we can see here also that we get only the packets that are coming from the pod that match the filter. So this IP address here is the response, for example, of the sample 19 service right here. Lastly, the final thing that I want to show you is we also have port counters. So oops, stop this. So you can see the VFP counters of the pod directly as well. There's a lot of stats, kind of network level stats that belong to the pod that are on the VFP port. So it can also indicate you the network health. So for example, I can see some TCP stats about the pod as well in both the in and the out direction. So yeah, that's all I had to show today. Any questions?
No questions, but that's very cool. That's a lot to go over. Is there a lot of how's the README on this repository? It seems like there's a lot of functionality in this tool.
Yeah, yeah, we tried to give some basic examples of all of these commands. So we have some docs as well as how to build it. And it's not very detailed, but the CLI has a lot of help commands on each of the settings and stuff. So yeah, reach out to me if you have any questions about this. I mean, this is just a pre-release tool. And I should also say, important to note, this is not a kind of a silver bullet to troubleshoot all networking issues, but it's more of a tool that's meant to enable you to identify where possible problems could be, like, for example, which node or which pod is misbehaving, at which point you can use more deeper diving tooling, like the the debug logger that James has worked on, or Periscope, or other approaches to inspect things at more depth. So this is more at a cluster level to help identify problem areas.
Yeah, I could definitely see this filling some missing use cases. Arvind, I see you just popped on.
Yeah, I think this is really cool, especially because we've been having trouble running, packet captures with Windows nodes. I think the biggest use I see of this tool is the fact that it takes away the complexity of, knowing Windows. You don't need to get on the node to do anything. Everything is either Kubernetes specific, and then you have the CLI, right? That you can run from a Linux instance also, which is, as far as your README goes, it says the client you can run on Linux. So yeah, this is really cool. I think this will really help with network debugging. So thank you for this.
Yeah, sure. And yeah, if you have any feedback, feel free to file an issue. We'll do our best to add it. So probably it's not production ready. None of the binaries in the releases are signed yet, but we're working on that. So
I was just going to ask if you'd be willing to post in SIG Windows announcing this, but maybe we can wait until the release artifacts are there. But I think you should definitely kind of announce this in SIG Windows once it's ready. I think a lot of people will be very interested.
yeah, we have some releases here, but none of the binaries are signed. So yeah, just for playing around for now. Yeah.
Any ETA for binaries?
For actual signed production ready binaries. I'm not sure. It depends
Any
on a
sort
few
of
things.
binary.
Oh, the binaries
basically.
are already published. Yeah.
Oh.
Already used them today.
Okay.
So the client is in the releases. Well, all the binaries are in the releases, and then there's a container image for the daemon set on the GitHub's container registry.
Okay.
I'll paste the links to the releases.
Mm-hmm.
Awesome, great demo.
Thank you.
Does anybody have any other questions for David? I think that there was one more agenda item.
Yeah, it was me.
Yeah, this is really cool. Thanks, David. Great.
Yeah.
We can link to this video if you don't want to record another one for the demo and the review. Yeah, so I just wanted, we've been working on this one for a while. We've been back and forth on the approach that we're going to take. But I think we finally landed on it. I've updated the KEP. I just wanted to have SIG Windows take a look at it, or anybody here, to make sure everyone's in agreement. In particular, hey, David, actually, you might be interested around, like, we're going to add Windows specific fields to the CRI, and in particular, the network interface usage. There's some fields we weren't filling out that I've added in. So maybe take a quick look and make sure those make sense. But this will allow us to eventually add Windows specific stats that we may be able to use to make various eviction decisions and things like that. But right now we're just trying to add support for the CRI only KEP, which is in alpha. So.
Yeah, this looks good. I mean, this seems to map pretty nicely to the endpoint stats that we have in the HNS API at a cursory glance. Oh.
So hopefully we'll get this merged and we can get the CRI changes in and get containerd updated.
Yeah, I think I'll just comment. I think we've commented on this before too, but the goal here is these the fields that are in the CRI API are really designed, and I think we want to keep them scoped to things that the kubelet would actually be able to act on for eviction or just resource management. I know that there's potentially a lot of other types of stats that we would want to collect, and at least for now, SIGNode has decided those are mostly out of scope for what we put into these resource fields in the CRI API. So just keep that in mind if anybody's commenting on this too. And yeah, thank you, James, for bringing this up. Awesome. I see David's posted the links to the daemon set and deployments in the chat too. Make sure to get those in the notes. All right. I'm going to stop sharing and stop the recording. I need to hop over to SIGNode now. Thanks everybody for attending. See you next week.